can be shown that the path of any projectile is that of a parabola. Let's look at a special case, the horizontal projectile, which means that the mass's initial velocity is horizontal with no y component. This means that the initial velocity in the y direction is 0. This also means that the y component of the velocity of the mass, same as that of an identical mass dropped from the same height at the same time. Since the acceleration in the x or horizontal direction is 0, it also means that an identical ball that began rolling at the same time as the projectile and having the same horizontal speed would always be directly below the projectile. Demonstration problem. A fully laden swallow is flying horizontally at 15 meters per second at a height of 12 meters above a lake when it drops a coconut. How far from a point directly below where the coconut was released will the coconut hit the water? This is a horizontal projectile since the swallow was flying horizontally when it released the coconut. The coconut then becomes a projectile since there are no other forces other than the weight or the gravitational force on the coconut. We again utilize the guess method for problem solving. G is given, U is unknown, E is what is the equation or equations, S is substitute in, and the other S is solve. Givens. The initial velocity, symbolically Vxi, is 15 meters per second. Y initial, the initial height of the swallow when it dropped the coconut when it became a projectile, 12 meters. Y final, when it's no longer a projectile. That means when it hits the water and there's a water force, so it is no longer a projectile. It is now a collision. S of y is minus 12 meters. The displacement in the y direction is the change in position from start to end, and that is a negative 12 meters displacement. Unknown. How far from a point directly below where the coconut was released will the coconut hit the water? This is asking for the displacement in the x direction, or S sub x. What are the equations? We must write the x and y components since this is two-dimensional motion. We need the displacement in the x direction. That equation is S of x is Vx initial, or Vxi, times t, where t is the time where the coconut hit the water. The displacement in the y direction, S of y, is Vy initial times the time minus 1/2 times the acceleration of gravity, or g, times t squared. We substitute into our equations using the givens to populate these equations. We start with the displacement in the y direction. S of y is minus 12 meters, which is given. Substituting in for v sub y initial, which is 0 times the time, and so this term goes away. Minus 4.9, half of 9.80, is 4.9 meters per second times the time squared. We solve this for the time. We have to take a square root here, and that gives us 1.56 seconds. We carry 3 significant figures. Since this is a 2 significant figure problem, we must carry 1 extra significant figure for intermediate steps. We take this time that the coconut hit the water and substitute into the displacement in the x direction. S of x is 15 meters per second for Vx initial times the time that it hits. We get 23 meters rounded to 2 significant figures.